SprayCam is an affordable, simple-to-use particle diagnostic system designed for thermal spray processes. During this video, I will demonstrate how to set up and align the SprayCam system. This simple and straightforward procedure will only take about 10 to 15 minutes. What you see here is the typical SprayCam system. It consists of a high-speed sensor head, pulsed laser diode module, control box, computer, and controlling software. SprayCam uses shadow graph photography to take images of micron-sized particles within a plasma or flame. The particles that pass between the laser and the sensor are backlit in such a way that they create a shadow. It is important to line up the laser and the sensor properly so that you generate the best possible image. First, place the sensor head and the pulsed laser diode on a flat surface. Then, using a straight edge or ruler, set the sensor and the laser facing each other about 9½ inches apart. Here, we are using an optical table, but using a precisely flat table isn't required. You can do it on a workbench or something similar. Now, everything should be aligned when you turn the system on. Find the cable with the circular, keyed connectors and connect one end to the camera and plug the other end into the control box. The two cables for the pulsed laser illuminator and the trigger get plugged in. Power on the system via the switch on the back of the control box, and the light on the back of the system will turn on. Next, connect the SprayCam to the computer using an Ethernet cable. It will take a few minutes for the computer to find the IP address of the SprayCam. Here we are using a short Ethernet cable, but the cable can be up to 100 meters in length, allowing you to move the computer outside the booth, while the remainder of the system remains inside the booth. Once the computer finds the sensor head, which can take a minute or two, it will usually say it has limited or no connectivity because it can't find the internet. At that time, start the SprayCam software. Click Play Images and turn the laser on. You can see the system is aligned as we have a consistent white background. If you move the camera, you can see the background is affected. And if you move the laser, the background is also affected. You can see when the system is aligned when the background is consistently white. If we place an object in between the sensor head and the high-speed illuminator, it will create a shadow. We can find the spot of optimum focus by moving the object back and forth between the camera and the illuminator. When it is perfectly in focus, you can usually see a small piece of lint or dust on the object. The particles we are looking at are very small, so focus is very important. The next step is to solidly connect the laser to the sensor so that when we move it into the thermal spray booth, the system stays aligned. Supplied with the system is a U-shaped bracket, which is meant for the typical thermal spray applications. In some cases, a closer distance or a further distance may be applicable. The mounting holes on the system are 1/4 on 1-inch centers, so that standard optical breadboard components can be used with the system. Users are welcome to make their own bracket, but the system focus and zoom will likely need to be adjusted. It is a good idea to put the screws in so that they are slightly loose, and then make sure the sensors are still in alignment before tightening the screws. Now as you move the system around, it stays aligned. Notice the U-shaped bracket is missing some rigidity, as it was designed, so that if an operator accidentally crashes a robot into the sensor, the bracket will break rather than the more expensive sensor or pulsed illuminator. Although the system has no laser safety issues, it is still not advisable to stare directly into the pulsed laser illuminator. And now at this point, we are ready to move the SprayCam into the thermal spray booth.